Hello everyone, this is Dr.Praveen Verma from ADARSH MANDIR, Mount. Today's our topic is derivation of the wave number. Now first thing, what is wave number? In 9th class you have studied about the wavelength. Okay, that is the distance between the two consecutive trough. Okay, or now suppose we have this wave, you can see. So in this wave, the distance between two consecutive drops, that is what wavelength. So the inverse of the wavelength, I am saying inverse of the wavelength, that is called as wavelength. So I have written here nu bar. The symbol I am using here is nu bar is equal to what? 1 upon lambda. You know, for wavelength we use lambda. In previous period, we have derived the formula of energy of electron, total energy of electron. So, it is the side again repeating. We have derived this formula. Remember, for n shell, energy of n shell En is equal to minus R Z square upon R. Okay? And we also derived the formula of radius, that is R is equal to m square h square divided by 4 pi square m z e square. So when we keep this value, it means the substitute value of R in this formula. So we have the formula of the energy, that is E is equal to minus 2 z square e raised to power 4 into pi square m divided by m square h square. And for hydrogen, the value of Z is equal to 1. So the Z square will be what? 1 is equal to 1. So now we have the general formula of the total energy of electron. Now in atom, you know, there are different orbits, and I already told you that when electron revolves in orbit, it does not lose or emit the energy. Or also the same, not gain. When electron actually changes orbit, it means when suppose electron in first orbit and after gaining energy, it is transferred to excited to next energy level, that is second energy level. So during this time, the energy is what? Absorbed. Or suppose when electron from what? Higher to what? Then energy is emitted. So this energy is actually emitted or absorbed in the form of energy particles. These particles are the quantum of photon. So, and the energy of this quantum photon is given as h nu. Here is h is Planck constant and nu is frequency. Okay, so it means if you see, we are actually calculating the wave number for this quantum or photon, which is absorbed or emitted. Okay, so now suppose if we have these two energy levels, so the energy that is absorbed or emitted during transferring this electron from one orbit to second orbit, so actually the energy of that quantum photon depends on the difference of the energies of these orbits. So we can say, if we want to find out the energy of that quantum photon, so that is equal to delta E. Okay, and that is delta E is equal to what? H nu. So and second thing, this delta E also depends on some E2 and E1, the energy difference of E2 and E1. So I just first I have to find the energy of this first orbit, that is E1, and energy of the second orbit, that is E2. So by this simple formula, as I have this formula, I can write two formulas for E1 and E2. So in this case, Z is actually 1. So Z square becomes 1. But the value of n changes. For even at the base of n, you have to take n1. So for the even I can write the formula even is equal to minus 2 e raised to power 4 into pi square n divided by n1 square h square. Okay. Now for second orbit, I can write E2. That is equal to minus 2 e raised to power 4 pi square into m divided by n2 square or h square. Okay, so I will write these two formulas, E1 and E2, and the energy difference will be equal to what? Delta E, that will be equal to E2 minus E1. So I have this first equation here. Now we have to substitute the values of E2 and E1 from here. So you can just substitute the value of E2. So delta E becomes equal to what? I have substituted the value of E2, that is minus 2 e raised to the power 4 pi square n divided by n2 square h square, and minus sign, and then again the value of E1, that is minus 2 e raised to the power 4 pi square n divided by n2 square h square. Now when you multiply minus minus, it becomes plus. Okay, so we get the equation third from second. Now next equation, we arrange this one. First we take the plus value, then minus value. We have arranged this one, so we get the equation 4. So in this equation, if you see n1 and n1 square and n2 square, okay, they are different. Otherwise, 2 e raised to the power 4 pi square n h square, that is the word same. So we just take it out or take common. So it becomes equal to this one. And now we have also put the value of delta E. I already told you that delta E is equal to what? H, that is the energy of quantum or proton. Okay, so in this case, when I substitute this one, so I get this equation H nu is equal to 2 e raised to the power 4 pi square n n1 square h square minus 2 e raised to the power 4 pi square n divided by n2 square h square. Okay, equation 4. Now, so when I take just common this one and keep the value of h nu, one more thing is there. Nu is frequency, and here actually when you find out the velocity of light, so the formula of the velocity is given as c is equal to nu lambda. Here c is velocity of light, nu is frequency, and lambda is wavelength. Okay, so we have to find out the formula of the nu. So nu becomes equal to what? C upon lambda. So I just substitute this value in equation 4. So I got the equation 5th, that is Sc divided by lambda is equal to 2 e raised to the power 4 pi square n divided by h square in bracket 1 divided by n2 square minus 1 divided by n2 square, bracket close. Okay, so that is the equation 5th. Now so in this case, if you just arrange this one, just cross multiply that. So h square into h equal to h cube, and just I transfer c here down, cross multiply. So the equation becomes 1 upon lambda is equal to 2 e raised to the power 4 pi square n divided by h cube into c, bracket in bracket 1 divided by n1 square minus 1 divided by n2 square, bracket close. Okay, so we got this equation 6. Now there is whole value, that is what? 2 e raised to the power 4 pi square n h cube into c, that is a constant, and it is represented by capital R. Okay, that is called as Wimper constant. So when I just replace this one by R, so I have this equation 7. So the final equation 1 upon lambda, that can you can say also mu bar, okay, is equal to R, bracket 1 divided by n1 square minus 1 divided by n2 square, bracket close. So that is the final equation, equation 7. Okay, so we have to use this equation when we have to find out the wave number of what? Quantum or proton. And the value of R is given as 109737 in centimeter inverse, because it is inverse of what? Wavelength, and you know wavelength is distance. So in CGS we use centimeter, and it is inverse of wavelength, so the unit will be what? Centimeter